Now let's develop automated comprehensive testing for F stack with the operator overloading we have defined earlier. So here constant S is defined, and then three stack variables S1, S2, S3 has a slightly different capacity though, but all of three have the same value pushed initially. So at this moment we know that S1 is same as S2. However, S1 is not the same as S3 because of a capacity difference. Now, if I do in S2, if I do push with some data, then S1 and S2 should be different too. So let's test up to there, compile and run. So it's verified. Now let's test for index operator with R value as well as L value usage of that. So here you can test it by reading the value from each element using I. 0, I is less than half of S. If I increment, then what I expect from S1 at index I is the value of I. That was the pushed data. And then at this moment, R value usage of square bracket index of operation is tested. So if I compile the program and run it, so up to there is verified. Now we can use L value usages of that. So let's copy the loop. And then instead of asserting, so let's assign a new value, which is 2 times I is assigned onto S1. Then now we can verify that, capping the 3 lines of loop again. Then we need to assert that times 2 is the one we just stored. So at this moment, the L value usage of index of operator is used. So updated value should be returned. So let's compile and run it. So that is tested. Now we should test the copy constructor and the assignment operator. So let's try for the copy constructor. In copy constructor, let's define a variable fc. Then let's have s1 as the initial value. What we need to assert at this moment minimally is that the copy constructor creates a variable with the identical value from initial one provided. So they should be identical. But if I change something on fc like a 0, let's assign some different value, then since fc and s1 does not share the array, they should be different. So at this moment, the two variables will have a different contents. So if I compile and run it, up to there is verified. So similarly, assignment operator overloading, we can test that. So let's define f stack A with a small size, B another small size, like that. But if I do A is B is S1, now A and B and S1 should be the same. First, let's assert that S1 is the same as A, and then S2 is the same as A. So let's check it out. S2, so no, it's S1. That's my error. So let's compile again and then run it. So that is verified. The assignment operator works in cascaded manner. But however, if I now change that A0 is some other value, then S1 and SA cannot be the same, and since they are not sharing the same array structure. Similarly, here I should have used the B instead of A. Similarly, if I change something in B, the different value, then S1 and B should be now different. So let me compile and run it. Then all of those are successfully tested.